Yeah, hi everyone. I you're answering. I like that. So you're not sleeping. Yes. Okay, so let's do this. Welcome. Thank you very much for being here. Today we'll talk about best practice in offline first and learnings we gathered in the past few years with a few really interesting use cases. Before we start, 1, 2 things. So, my name is Ola Gasidlo. I'm a platform engineer at Mozilla and work on the web compatibility team to make sure the broken web gets fixed. I'm also part of CSS Conference U, organizer of a lot of conferences, meetups, things, Open Tech School. Yeah, but you might be like, what? It took me like, I think, a month to actually pronounce that. Not like super slow. So, imagine you probably ever experienced a website that was broken in one browser but not in the others, right? Who did that? Did you report the bug? Did you write a dirty hack? Yes. So the Web Compat project is an open source project that makes sure that specs are implemented in the correct way in all the browsers. So when you find a website that is broken in one browser, but it works in others, just report that. Go to that site, report. We help to fix and annoy other browser vendors to actually fix that. And if you're interested in actually helping, let's talk. So today, I would love to tell you a little bit about the actual state of offline first and how our point of view changed in the past 4 years now and how it's adapting in the real world. Before we start, I'd like to mention that in this talk, I will speak about death and pandemic. There won't be any graphical display, but I just like to mention that. So if you feel uncomfortable with this, and also because of motion sickness, animated GIFs, if you want to leave, cool, totally get it. Happy to give you a short summary after the talk. But yeah. So let's start. The internet turned 25 last year. Amazing times we all live in. In this time, our relationship with the internet, it's changed a lot. We do different things with different devices than like 25, 10, or even 5 years ago. And it's a part of our everyday life. We rely on our devices, but it needs changed. 4 years ago, when the offline first movement got like broader attention, I gave my first talks about the concept. That was 2013. What was our idea back then? Why did we need the offline first concept so badly? First thing was the rise of the mobile devices and the usage. There are countries where people actually do not use a desktop device like at all. When you think about it, it totally makes sense. For example, a phone is way cheaper than a laptop, and it basically covers your needs for whatever you want to do with it. There's also the issue of no constant connectivity or really poor network coverage. Here, offline first felt like a huge enhancement to application and adaptation to a new behavior. 4 years later, in 2017, what do you think? Do we still need the offline first concept? So tell me, by raising your hand, yes, I like to ask questions, who of you is already building offline first applications? Just raise, just very few. Okay, cool. Who of you thinks they're following the correct approach? That's good. Hands is good because actually there's still no perfect path. There are a few things we figured out over the time, but we're still trying to figure things out. So you're probably right. Who of you thinks about offline first as progressive enhancement? After seeing offline first in the wild, we've realized it's not just about a specific and special use case or the rise of the mobile devices. It's just the whole approach. It's so much more. As Jake Archibald said once, offline first means getting on screen without a network request. The more that it's there before the network, the more offline first it is. This means every web application should work after the very first visit, just to use the network just basically to get and set new data. Everything else is online first. Remember me asking you like a long time ago, 3 slides or something, if offline first is progressive enhancement? And quite a few people were like, yeah, totally. What if I tell you that you're actually wrong? Yes, exactly. You might sound confusing. Why is the offline first concept not progressive enhancement? I mean, actually, it's the other way around. Let's take a step back and see, why do we need offline first applications? Normally, we use applications for our everyday life, right? To make it easier, better, like checking in with your family members, other loved ones abroad, or maybe just text a partner during the day. Using Slack, RSC, etc. at work, especially in remote team, that all comes down to communication. We also need applications for tracking data. How much money did I spend? Did I drink enough during the day? How many steps did I make? But also, how can I fix my bike or my washing machine? How do I translate that even, or did I spell this right? Basically, that is all about information. Posting selfies from your last vacation, tweeting your thoughts, etc. Checking in when your symptoms, when you're sick, or even checking the internet why your kids act out, probably. I do that. This all comes down to empowerment. And the most important thing there is, cat gifts. And it's a basic life need, and I think we can all agree on that. This sums up to love. So when we look at those points, communication, information, empowerment, love, sounds like something we all have in common, right? When we break it down, it all comes down to help satisfy our very basic human needs for safety, belonging, esteem, and self-actualization. Maslow defined all those points in his hierarchy of needs already in 1943. So, since when is helping people to fulfill a very basic human need progressive enhancement? But we all love to sell it that way, right? So developers jump on the progressive enhancement train and redo the application every 6 weeks in the new cool framework or tool or whatever, and without knowing what the real issue actually is. And I'm kind of tired of this half-done applications, no documentation, nothing at all. Released out in the wild because someone wanted to refactor the application just really quick. Right? Right? Temporary. It's always temporary. So we have all these really bad and super slow applications because of bad planning and really messy architecture. Rethink, we do not need a new Google Mail or Twitter or whatever. Trust me. We tend to forget that our jobs are basically about humans, people. It's not about frameworks, tech, design patterns, or even discussions about semicolons. Do not build a town when you actually just need a house just because you can. Especially because usually you end up with the gorilla banana problem. Any one of you knows the gorilla banana problem? You know it. Let me explain. I love this one. You wanted a banana, but what you got was a gorilla holding a banana and the entire jungle. So every time you use like a whole infrastructure, like a framework, to solve one problem, you get all this implicit environment that they carry around with them. It's about using the right tool for a job without building a town, just because you can. It's all about keeping this thing simple but solid, basic but optimized. This is why I think putting offline first in the progressive enhancement slot is pure BS. You know what the progressive enhancement part of your application actually is? The network. So you might ask yourself, why should I care my applications work? Are they? Do they? Do they? Ever checked your application with a bad connection or none at all? How productive are you when, for example, just one service like GitHub is down? or not to mention office Wi-Fi. How easy it is in your everyday life to communicate, for example, with your friends at a concert, when everyone is just sending live streams of a concert via phone, and you're like, where are my people? And besides us, with good connectivity situation blessed people, surprised there are others. Just 43% of the population has access to an internet connection, and just a very small amount of them to a truly fast and steady one. Data is expensive. It is. As you can see here on this list from Ben Swartz's talk about performance metrics, Germans would have to work like less than an hour for 500 MB, but people in India about 17 hours. Let's assume you have a 500 MB plan, right? So what can you do? You could visit almost 7 websites per day during that month. Nothing else. You could watch one talk, basically like 22 minutes. So one talk per month, and data would be gone. Or you could make other people really happy and write a lot of emails you're all procrastinating on. Without attachment, of course. So your application should provide the base and work offline per default. The network is the one to enhance your application with new and outside data. No matter which technology stack we actually use, peer-to-peer network, direct connection to the server, or a USB stick, whatever works to transfer your data, it's fine. It's not important how you transfer the data, basically, or the application on your device. It's important that we save it locally and enhance that sync through the network. I know, mind-blowing. So we covered theory. Yay. Let's check out what is happening in the real world and how others solve offline issues. In the next minutes, I'll show you like real approaches and really impressive ideas. So let's start with the router. Imagine, like a beautiful morning, you decided to work remotely, sitting in an internet cafe. So, okay, you need probably first to check your emails. Connect your laptop to the router, open your email application, and send the request to get your emails, close the laptop, and come back in the evening. And you're like, wait, slow. It was morning, right? Exactly. This happens because there's no physical connection to the internet like a cable that the internet cafe is using. They just have a router that saves the request and connects via Bluetooth to a bus. It syncs and the request goes, like off it goes literally. The bus arrives at a stop after half of the route to the hotspot with a physical connection and syncs with another bus. Also exchange not just the data but also passengers and luggage. The buses sync via Bluetooth previous requests and results. Both buses return, literally, and you get your emails. Hopefully, when you were able to authorize. The tech behind the SNC service is a combination. By the way, it's actually a thing. People are using this. It's a combination of NAT zones, DTN routing, and the DakNet. So what are our learnings? Actually check your requests. Besides of the fact that you should be aware what you're actually doing. Do you need the 20 requests, or maybe just 2 would be enough? Please serve uglified and minified files. And do you really need this 5 MB background for mobile? Really? Beware of Li-Fi. You should be aware of Li-Fi, which is the state where your device checks your connectivity situation and tells you, yes, you're definitely online, pinky promise. But actually, no data is passed through. We could go with checking the bandwidth after the very first ping, right? Could work. And we could develop something similar to media queries, right? Device sizes, but like media queries for device sizes, but just for bandwidth. So we could load assets to detect true bandwidth. That would be cool. But bandwidth can differ per request, even per package, especially when you're moving, for example, on a train. I even experienced that here today in cinema. we would need to ping not just per every request, but basically constantly. So it will kill your performance, the whole application, and even the network. You can't rely on your request to come back. So either you add a timeout to kill your request or make your whole application fully independent of requesting data. This is why we need to separate updating cycles from the assets and data. The update of assets is way less important than actually getting data. Save a basic set of UI locally to go easy on your storage, just the basic one, and head start with web fonts and images, whatever you need. Offline should be the default state, and we need to make the bandwidth assumption by device we detect. Take responsibilities of your caches and keep them clean. What could be better to use to manage your caches than Service Worker, right? No intro in Service Worker today. I think Marcus is here, he can totally do that. Just one thing. If you want to use app cache for quite a bit, just because browsers are dropping the support really hard, but also for migration from app cache to Service Worker, use JCache. Images. Images are really hard, especially in the offline context. Saving images in the in-browser storage, good way to go, but still very painful because of different story limitations, different story limit implementations across the systems, across the versions. So porting decorative images like icons, logos, etc. to SVG and CSS, great way to cut off a bit of the overhead. Encoding assets in base64 and storing the string in the in-browser storage of your choice could be a way to go. For example, saving fonts like this, loading them straight from the storage, improves your performance enormously. You don't have to jump anymore. This is even possible for images like a logo, but please be aware. Do not do this for all of your images. Don't build a town when you just need the house, just because you can. The strings are huge, as we already know, and in-browser storage are limited. Plus, decoding base64 on the fly is a really heavy task. So it slows down your entire site, and especially in combination with DOM manipulating frameworks, like React, you can find yourself running into race conditions here, like really badly. Okay, next use case. Bit heavier, so just to let you know in advance, the next use case is about the pandemic. 2014 and 2015, the Ebola pandemic in parts of West Africa was a really scary issue. I was involved in a project by the NGO eHealth Africa to build 2 applications to stop the pandemic. The first application was to solve a specific issue, to provide information for the population, because information is the key to prevent a pandemic to spread and kill. The process was the population was informed about one specific number they could call and just ask questions about symptoms, report someone sick or even dead. The call center tracked the calls within the application we've built, collected all the provided information from the caller and sent out a team if needed. They'd added also information through the application like name, location, edition information, phone number, so they could even call back for any further issues. Data analysis and filtering was really easy thanks to that application. They fought there with issues like unexpected and constant power loss. The generators jumped back in after some time, but we could not afford to lose data. Just one case could have caused another outbreak and many deaths. Our first learning here was decouple server and client to serve the needs of eventual contingency. Built in a task and message system that can act independently on connectivity situations. For example, for data, CouchDB, especially in combination with Pouch, provided their usability in the real world really well. CouchDB is a NoSQL database that replicates, which is exactly what we want for sync. CouchDB comes with a suite of features such as on-the-fly document transformation, real-time change notification, and we need that for our message and task system, but also for decoupled architecture. CouchDB is an open source JavaScript library that is inspired by Couch. So same API, but very different implementation. It's designed to run well within the browser and store everything locally when you're offline, especially. It syncs with Couch thanks to the replication protocol and when it's back online, so you don't have to take care of that by yourself. So one of the learnings was also to save data documents locally. With Pouch, we actually had documents that we could store locally. We don't have to worry about flushing the caches by accident. One of the biggest issues with syncing data was merge conflicts. Because Pouch and Couch speak the same protocol, sync was on that part really easy. When we're back online, we didn't have to take care of it. The second application we've built was actually to track patient data in the field. After examining the infected patients, they had to stay in quarantine for like 21 days. The team added the data to a general database through the application, plus got like lab results for very different endpoints and very different file types. So that was really messy. The data was imported and saved in a global database, synced all across all devices. So what do you do with a mess? Clean it up. Second learning was about schemas there. Define flexible data schemas. We added an organization system, an interface to map the data in one defined schema. The schema was flexible enough to be extended if needed, thanks to the NoSQL database behind it. Data was imported automatically when it arrived, mostly per mail, sometimes just USB stick that traveled for 2 weeks. And we added data on the fly. Constant automatic testing and high test coverage for the importer and the interface was a must. The schema and the testing helped us a lot to prevent merge conflicts before the get-go. Couch and Pouch helped us to take care of the sync, merge, and flexibility. Big bonus also, the schema helped us with making filters and analyze the data. So visualizing it was really easy. We helped actually to curtail the pandemic because of clean data structures and constant testing of applications. And if anyone tells you ever again that testing and clean structures don't matter, now you know what to reply. Okay, I think it's almost lunch-ish, so you might hate me for the next thing, I'm sorry. The pizza. So, okay. Back to fun part. You all love to order to food, right? Who loves to order food? Yes. Okay. Did you ever check the local storage while ordering? You should. Like just to see what gets stored, your items, things. A friend of mine did that once and went a little bit further, just curiosity. So he was actually wondering if they're validating everything on the server. And he manipulated the checkout, subtracted just 1 cent, and sent it out and waited. Pizza came, and nope, no server-side validation. Could have been a very cheap meal. What do we learn? In contrast to the limited possibilities in the use case before, this company could have validated the data on the server, right? But this is sometimes not possible, especially when everything needs to work without actually request. Security is still a very new topic to offline first, and not many tools are provided yet. I'm super happy to chat later about that, because any input is good input. You should definitely also watch Marco's talk at the end of the day about mobile security. So, a lot of us seem to hate CORS sometimes. It provides already a really great set of features to make your web applications more safe, but it does also not solve the issues with in-browser storage manipulation. One way to go would be to encrypt your data. When you use Pouch, you can add, for example, CryptoPouch, which encrypts your Pouch documents. Big downside here is the documents get encrypted, but not the ID, so you could reverse engineer really quick. But at least you can't change the data anymore. When you want to encrypt data, you might also want to log in, right? Which does not work without a request to the server. There's a way to use tokens in a client. You could use JSON Web Tokens. It's an open industry standard method for basically representing claims securely between two parties, and it's pretty much what we want. It makes decoupled and secure sync and communication possible. Okay, those are the big ones. I still have one last use case because I think this is the most hilarious, amazing, and most impressive one I've ever seen. So I would love to show you that one. It's about the rally. Any one of you ever heard about the Mongol rally before? 1, 2, 3, just very few? Okay. So the Mongol rally was an unconventional rally where people started either from London or the Czech Republic with a really old car to Mongolia. The main intention of the rally was a donate your car program. So every car that actually made it there could be donated without importing duties, which was really cool. 2009, a team from Spain took part in the rally. Nothing special at first glance. Well, the issue at the rally was they had to cross a lot of countries, obviously, with different receptions, different payment models for data volumes, etc., etc., etc. So they needed a way to communicate with their loved ones, so they could say like, hey, we're alive and well, or could you actually bail me out of jail? So they built a system that could encode an ASCII message in 8-bit binary code, ran that through 8 phones that actually called just one number. To save money, they didn't establish a full connection. It was mainly about letting it ring. Though short ring was a 0, long ring was a 1. The other end just checked the number, basically. The numbers were set for the order of the bits, decoded the binary back in ASCII, and sent out the message. I know, this is mind-blowing, right? People. What are learnings here? That's basically just one tiny, no, actually it's the most important learning I've ever seen. Rethink how to use technology by thinking about the issue, not about the tools. Unidirectional communication, it's so basic, it's so simple, right? They fixed it already in the beginning by thinking about the real issue and not the solution first. Okay, time is, I think, yeah, fine. We'll have some questions in a moment. And you can also like find me, I mean, I'm the one with green hair, so you probably find me really quick. And remember, it's not about frameworks, design patterns, tools, semicolons. It's all about humans. Thank you. So questions? If not, it's totally okay. I know you're hungry. And I'm around. You can also tweet. I think we're good.
Actually, I have a question.
Okay, cool.
In my job, I work with mobile devices, and one thing that we would like to do is to save some data locally and then send it on the server when we have connection.
Yeah.
It's an actual case in travel business. Because if you're out of your country, you don't have connection, you have to, okay. If I use this application on more devices, I could incur in a problem about versioning of which data is the most recent, the most valid. Do you know, I mean, do you think on a way of solving that problem? Because I guess that I could save on different devices this data, and then I need to decide which one is the actual valid data.
Versioning of data is really hard. This is why I love to use Couch and Pouch. It's not like you have to use this because blah, it's, I don't know. I don't consult with them, so. Because they have revision numbers. So they take care of this and they're aware which revision number you're actually on right now, which device is on which number and how to merge things. So it's kind of automatic on one way, but you're also able to, when you have merge conflicts, to solve it within your code by yourself, to write a logic just for that. Plus, like, the detection is always like really hard, because when you're back online, you basically would need to, for example, use a WebSocket or long polling or whatever, just to see if there's a connection established, right? The cool thing is that because of Pouch and Couch speak the same protocol, when Pouch is like realizes I'm back online, it just pings basically. Couch realizes, hey, there's something, because it sends just a task and a short message. It gets one back. It knows, okay, I can sync now. Let's do this. And just talks to each other. So you just don't have to take care of this anymore. There are different solutions, but pretty much all of them are way, way harder, because either they don't have the versioning, or you have to use a different protocol to actually establish the connection and ping.
Thank you.
Yeah, you're welcome.
Any other question?
Cool.
Okay.
So enjoy. Thank you.